Good evening in Slovenia. Good morning to Dr. Elisabeth Bick to San Francisco. And welcome to everyone who is watching us online. We will now begin with our last session for today, which is titled The Dark Side of Science, Misconduct in Biomedical Research. It will be presented by Dr. Elisabeth Bick, who received her PhD in microbiology from the Utrecht University in the Netherlands. Then she worked in various microbiology labs in the Netherlands and the USA, including the lab of David Relman at the Stanford School of Medicine for 15 years. In March 2019, she became an independent microbiome and science integrity consultant. Owing to her remarkable natural ability to identify both image duplication and image manipulation through visual screening, she helps to uphold scientific integrity by searching the biomedical literature for inappropriately duplicated or manipulated photographic images and plagiarized text. As of October 2022, her work has resulted in 923 retractions, 121 expressions of concern, and 956 corrections. The Slovenian news network N1 published an inspiring interview with Dr. Bick this July, which I highly recommend to all our participants. And lastly, as I have mentioned many times throughout our event, you can send us questions for Dr. Bick online through the Slido platform using the code 2509532, which is also noted in the title of the event. Dr. Bick, please, the floor is now yours.
Thank you so much for this introduction, and I will share my slides. So I hope you can see them. If not, let me know. Yeah, so you can follow me on Twitter. That's where a lot of people might know me from. I'm on Twitter at microbiome without the E, digest. And I also run a blog currently, Science Integrity Digest, where I post about my findings, although I'm not a very prolific poster, as you will see. But at least you can find some of the stories that I've unraveled there. So, let's see how I can share this. Before I start my talk, I do want to have my disclosures out of the way, because I'm not associated with a university or an institution, so I don't receive a salary. I'm a consultant, but how do I make my money? So I receive consulting and speakers fees to give talks about science integrity for universities and publishers, or to investigate cases of suspected misconduct. And I'm also on the editorial board of eLife, which is a journal. I receive donations through patreon.com, which is a website where people can support makers such as artists or writers. And I guess I'm sort of a maker too, or a breaker of science, if you will. And people can donate money there, and I receive most of my current income through Patreon. I have also worked at a company called Biome, and that company got raided by the FBI, and the founders have been charged with insurance fraud, but none of the employees have been indicted. So it's, yeah, I've worked there, and it will be on my resume, so I'll carry that scar on my resume. But I also have 4 patents from that period, which I'm sure have not are not worth any money. And then there's many other people who do the work or similar work as I do. So you've just heard Anna Albakina speak about paper mills and hijacked journals. And so there's many people who either voluntarily or through their work donate some of their time trying to find the rotten apples in science. And I've listed a bunch of them here. There's many people who do that either under a pseudonym or under their full name. And the ones that work on images, as I focus on, those names I've put in bold. And you can imagine that this work, which is criticizing other people's papers, is not always going over well. So you can also imagine why some people choose to do that under a pseudonym. And some people work on predatory journals, some people work on plagiarism, on paper mills, hijacked journals, images, citation rings. There's many problems that can be found in scientific papers, even after they have been published. So I want to give credit to all these people, and there's probably many more that I forgot to add. There's a whole army of people sort of doing similar work, and I want to give credit to all the work they do. So why do all of us care about science? Because at least for me, science should be about finding the truth. And if you do fraud in science, if you make up a paper, or even if you have an error in your paper, we should be able to discuss these things, because that's not about finding the truth. Errors and fraud are things we should discuss, because as scientists, we base our work on the work of others. We will always cite other people's papers, and we will sort of work on the generations before us who have done science. Our work never stands by itself. So publications are the way we talk to each other, and they're the building blocks of science. We communicate through each other, with each other, through publications, and we build on each other's work. So I see publications as bricks in the wall of science, where we build, every generation of scientists will layer a new layer of bricks. And if some of those bricks contain errors or contain even fraudulent or made up data, that might mean that other people could waste a lot of time trying to reproduce those findings. So if there's a problem or suspicion of fraud, we should be able to discuss that. Now, I had always thought that people were always honest in science, because it is about finding the truth. And I think everybody starts their career in science that way. But there is fraud in science, and I hope to make you aware of that. Now, in the US, and I think most European countries, science misconduct is defined as one of three things: plagiarism, so not citing other people's text, but taking their text and presenting it as your own; falsification, where a person does an experiment but changes some of the results to make it look better; and then fabrication is where a complete paper is made up. So data is just never measured. It's just made up and made to look realistic. Now, why would people cheat in science? I think it's driven by this pressure we all feel to publish. It's publish or perish. If we don't publish, our career is not going over well. And there's specific situations that I want to highlight. And one in particular is where, as a junior person, if you work in a lab with a very demanding professor who wants to see certain results, who does not want to hear that the experiment didn't work, a person who is very demanding and very maybe a bully, not a very pleasant person. If you have such a person as your professor, that might mean that you want to please them in order to get a good grade, or to get a paper, or to get something on your resume that looks good. And I feel in that situation, which is very common because academia is very hierarchical, we're so dependent on our professors to get a good mark on our resume, that you can imagine that maybe there are situations where a person feels the need to Photoshop or to make up results to make everything looks better, and to please the professor. And so you might see these cases where you see multiple papers from one lab that all have different first authors, so different people who actually did the brunt of the work, but where the last author, the senior person, is always the same. And so that person, the senior person, might not have actually done photoshopping or falsification or fabrication themselves, but they're such an unpleasant person that they might force all the people in the lab to do that. And we can have a long discussion on who is responsible. Ultimately, all the authors on a paper are responsible, but the senior, the corresponding author, which is usually the professor, the big name, that person in the end might not have done the misconduct themselves, but they are ultimately responsible. So it's always a hard question to answer who was responsible for this particular figure. And those investigations can take a long time. But I want to be respectful for all the authors on a paper, because some of them might not have known that there was misconduct. And it's hard to know who was really responsible, although sometimes you have an idea. But that's why I usually make it about the papers and the figures and not about the authors on these papers. So, but in some cases, of course, there have been investigations, and so there have been cases of misconduct in the news, and I've listed 4 of them. And in each of these cases, it's very clear after a long investigation who was responsible. So in these cases, I feel comfortable presenting these names. I was not involved in any of these cases myself, but it's just to show you that some of these cases can have, misconduct can happen in any field of science, in any country. And they sometimes result in big consequences. For example, the Andrew Wakefield paper published in The Lancet, in that paper, he claimed that autism was correlated to vaccination of young children. And it turned out that a lot of these data in his paper on 12 children had been falsified or fabricated. And still, a lot of people believe, even though this paper has been retracted, and it took 12 years to retract it, still a lot of people believe that vaccines have as a side effect that they cause autism. And so a paper like that, a fabricated paper, can have far-reaching consequences because it's spreading misinformation. We've all know about misinformation, but this is already happening for a long time. And even though there have been many other papers showing that autism and vaccination are not correlated, this paper is still having a big influence on the way that parents, are willing or not willing to vaccinate their children. So it is important that we raise concerns about papers very early, preferably even before a paper gets published. And we've just heard from Anna Albekina how peer review can completely fail sometimes, and we need to do better in that respect. Now, I got involved in being interested in science misconduct first by hearing about plagiarism and scanning papers and PhD theses for plagiarized text. And by accident, one day in early 2014, I was scanning a PhD thesis that had multiple chapters, and these chapters had been published in scientific papers. This PhD thesis also had rampant plagiarism, but it also had these images, these photos of Western blots. And if you're not a molecular biologist, you might not know what a Western blot is, but I hope you can see that some of these images here marked in red had been reused in different figures, published in 2 different chapters and also papers. And this particular blot here has marked in with cyan, with turquoise. This particular blot had a little dot that was very recognizable. And I found the same dot in another figure, but it was representing something else. Here it's representing different compounds being added, and here it's representing a time series. And the same blot was also representing another time series, but then it had been flipped, it had been mirrored. And so it's the same blot that was very recognizable, and it appeared to have been done intentionally, especially with this mirroring. And so these papers, I reported them to the journal, and they were retracted. And I thought, that's interesting. How often does this happen? These papers had been peer reviewed, nobody saw it, but maybe I have a talent to spot these duplications, and maybe I should do a search for these duplications in published papers to see how often does this happen. And I found several examples of these duplications, and they roughly fell into 3 categories. So I have listed them here. Category 1 is a simple duplication where panels, and I hope you can see my cursor, but these 2 panels here on the left, in the left example, marked by me with red boxes, And these two panels marked by me with blue boxes are identical. The labels suggested that these were all different experiments. Now, this is an example where the exact same photo has been used to represent two different experiments. So it's inappropriate, it's a duplication, but it's the exact same photo. There's no shift or something. And so these might just be honest errors. But moving on to the example here in the middle, that's an example of a repositioned one. This can be a shift under the microscope. It can be a rotation. It can be mirroring, stretching. All these things is a repositioning, like the example I just showed you in the previous slide. So here we see 4 photos representing 4 different differently treated cells, treated with different amount of radiation. And these 2 photos appear to overlap. And these 2 photos here on the right also overlap. So instead of 4 photos, we're actually only looking, well, there are 4 photos, but it's at best only 2 specimens because these 3 panels all overlap with each other. The sample was just moved under the microscope a little bit. Now here on the right, we see an example where there's duplication within a photo. So in panel A, you see that these 2 lanes, lane A and lane 1 and lane 3, look identical. There's lots of little dots that exactly match. And in panel D, these 3 lanes also appear to match with each other. So now we're looking at duplication within a photo. Now, if you think about these 3 different types of duplications, the simple one could be an honest error. Maybe somebody didn't label their samples very well or their photos. But the altered, the photoshopped examples, the type 3 examples, are very likely to have been done intentionally. With the repositioned one here in the middle, could be either way. It could be intentionally done or it could be just sloppy. And it's sometimes hard to tell if it was done intentionally or not. But at least these 3 types of duplications help me look at these examples and have an idea whether or not it was done intentionally. And sometimes we also see these 3 different types of duplications in plots, in line graphs, although it's much harder to catch them. Here, for example, is a repositioned plot where some spectrum or some plot of some kind where there is stretching. And here you can see a line graph where parts of plots appear to have been duplicated, especially in the noise. That's very suspicious. Now, here's an example. You can test your image duplication skills here. So I have an example here of a photo, a bunch of panels. You can see a figure from a published peer-reviewed paper. And all the examples that I'm showing have been peer-reviewed papers published in reputable journals. So not in predatory or hijacked journals, like PubMed indexed journals. And you see a bunch of panels here. And you can look at the labels. They're all supposed to show something different. And I hope that some of you at least have spotted that there's 2 panels that are identical, and I have marked them here. So these 2 panels look to me like the same. Now, again, this is a type 1, a simple duplication, the exact same photo being used twice, and this might be an honest error. I do want to stress this is not necessarily misconduct, but it's an error, and of course, it's not going to make a big difference in the interpretation of this particular paper. But it's an error that I feel should be corrected. That's a simple thing to do. But I wrote to the journal and the journal did not respond. So I reported this several years ago and the journal never did anything with this. Okay, well, that's disappointing. Here's another example. This is a type 2 duplication. So there's a bunch of panels here. You can see they have all different labels, different time points. And you would not expect any of these photos to look identical. Maybe a time series of cells might look similar to each other, but you would expect some growth and some moving around of cells. And if you look carefully, you might see that actually these 2 panels marked here in green are type 1 duplication, the exact same photo. But these panels here marked with red all appear to be showing the same group of cells. And in one case, it's even a different experiment. So that suggests that this, I don't know if this was sloppy or intentionally done, I usually remain neutral, but I will remark it to the journal when I report it. And the journal actually here, this is Infection and Immunity, retracted the paper, but it took 3 years after I reported it. And yeah, finally, they did an investigation and they retracted the paper. And I think that's a good outcome. Here's another type 2 duplication where there's an overlap between 2 panels. And we're looking here at photos of kidneys of, I believe, mice. And this is a paper by the Yale School of Medicine. And so we are looking at 4 different photos, 4 differently treated animals. And there's 2 panels that suggest, the labels suggest that they were differently treated, but there's a tiny overlap here between these 2 panels. And that suggests that, yeah, these are 2 photos from the same specimen. Again, I'm not quite sure if this was done intentionally. That's up to the journal to investigate. Maybe they, the authors just didn't label their samples well. But in this case, again, the journal did not respond. I reported this in October 2015, and the journal never responded or took any action. So this paper is still out there with its duplication. And sometimes these duplications or overlap, in this case, a type 2 duplication, can be pretty wild. So we're looking here at images of migration and invasion of different cells, differently treated, different cell lines. None of these samples should look identical, but there's many overlapping panels here. And this goes beyond what I think is an honest error. I would not trust anything from this lab, and I would certainly not want to base my research on this particular figure. And so the journal, in this case, PLOS ONE, agreed with me and retracted this paper. But as you can see, it still took several years of me reminding PLOS ONE, I've sent you a bunch of papers, look at them. And finally, they retracted this paper. So I think that's a good outcome for this particular set of overlapping images. Now, sometimes we can look at duplications within a photo. So we look here at 4 different photos of fungal spores. And yeah, each of these photos might look, at first instance, might look okay. But if you look a little bit carefully, maybe you have spotted that some of these panels contain duplicated spores, duplicated elements. So panels B and D both contain duplicated parts. So it appears to me that this photo might have been photoshopped. And actually, when I wrote to the journal, and they wrote then to the authors said, yeah, we photoshopped a couple of fungal spores to make the photo look better. Here are the photos without the photoshopping. So they've just removed one of the spores. And yeah, I don't know, but the journal accepted that. And they republished the figure without the duplications. I firmly believe that photoshopping in scientific papers is not allowed. I would have, if I was an editor, I would have retracted this paper, but the editor was very kind to the authors and allowed them to send in a new set of figures without the photoshopped elements. So this paper got corrected. And there can be other kinds of duplicated elements. So maybe you have spotted that in the left image, there's a duplicated blob of cells marked here. And yeah, I don't know. I'm not quite sure why people would do that. Does the photo look better with the photoshopped element? I'm not quite sure, but this is a type 3 duplication, and I feel that should just not be happening in science. But yeah, the journal just did not take any action. They didn't reply. They didn't take any action. This paper is still out there with its duplication. Duplication can happen in plants too. If you work on Arabidopsis, a very popular plant model, there's photoshopping in plant science as well. Several parts of these images appear to have been duplicated. And I reported this online to the journal, but it has not been addressed yet. But yeah, this appears to be a severe case of photoshopping. And again, be on the lookout for these things, because this actually happens in scientific papers. Then there's this example. This is a southern blot, a blot of DNA being probed with other DNA. And if you look carefully, there's duplicated elements all over the place. And some bands and some DNA smears have been duplicated. This is a fairly popular paper cited by 116 others, but not yet addressed. And yeah, that's not a good thing. Again, would not want other people or myself to base my research on a photoshopped image like that. And I should say a possible photoshopped image, but I feel the evidence here is pretty strong. And these things can also happen in big name, high impact journals. So this is a paper from Science, from a very highly regarded institution in the Netherlands that does research on evolution and genetics. And so this was a very highly regarded institution in the Netherlands, published in Science. And there's a duplicated part of two of these panels. And it appears that this is the original and this was just photoshopped in. And Science finally, after me, again, sending several reminders to the editor-in-chief, retracted the paper, but more than 5 years after I reported it. So you need to be very persistent and keep on sending emails. And it's frustrating because I feel, these things are, for me at least, pretty clear. And it's too bad that journals don't seem to respond very well. Here's an example of nanoparticles, a very popular topic for photoshopping apparently, but you can see these outrageously photoshopped images, and this paper finally got retracted pretty recently. And then there's these, this particular photo is one of my favorite, where a photo was published before laser treatment to remove brown spots in somebody's face. And after a wonderful laser treatment, the brown spots were, at least most of them were gone. But it appears to be the exact same photo. It's just cropped a little bit differently. And the bars over the guy's eyes are also a little bit differently. So you have to look carefully to see that this is the exact same photo. It's just cropped differently. But the guy is wearing the same shirt, and you can see it's exactly, folded the same angle. It's almost impossible. If the guy was really wearing the same shirt 6 months later, you would not expect these photos to look so similar. And this paper got retracted. Took a lot of convincing the editors that this was the same photo. And then there's examples like these. This paper is from the PhD work of a person who later went on to found a company called Surgisphere. You might be familiar with that case. So that was published years later. It was in the 2 years ago. There were papers saying Surgisphere claimed to have had this huge database of patients from all over the world, different hospitals, to look at whether or not hydroxychloroquine could work as a treatment option for COVID-19 patients. And it turned out that that database had been falsified or fabricated. It's still unclear to this date, but the papers had been published in the New England Journal of Medicine and in the Lancet. It was 2 papers that were connected to each other. And both papers were quickly retracted. And that made a lot of headlines that 2 big impact journals had retracted papers by this particular group, and that the data was probably made up. But if you go back into the history of this particular author, you find these images from his PhD work. So of course, that was much older than the Surgisphere papers. But there appears to have been severe photoshopping in these images, lots of duplicated elements. And unfortunately, the journal corrected this. I feel this is such a severe case of altering data, of manipulating data, that should not be addressed with a correction. But it's hard to fight editors on these point of views. They seem to be not very strong in their actions. There's flow cytometry, or if you could call it flaw cytometry, because you have these apparently manipulated images where parts of these panels appear to have been duplicated, but not all other parts. And this paper got retracted. This is actually from the Karolinska Institute in Sweden, so pretty high up. And this paper got retracted. But again, it took 7 years to get it retracted. So I did all these papers. I scanned, well, not all of them that I showed here, but I did a large survey of scientific papers to see how often I would find such examples. And I did all of that by eye. Back then, this was 2014 and 15. I just scanned papers by eye. And not everybody believes that I could scan 20,000 papers. I was still having a full-time job. I did it as a hobby. But I did because I only look at the images. I don't really read the papers. And I only screened papers that had photographic images of Western blots, of tissues, of cells. So mainly focusing on molecular biology journals and papers. I screened 20,000 papers by eye, spanning 20 years, spanning 40 different journals and 14 publishers. And in that set, I found 4%, 800 papers, to contain duplicated panels or photos within that paper. So not across papers, not between papers. Within that paper, they contain such a duplication as the ones I've showed you in the previous slides. Now, there were these three different types. So we made an estimated guess that about half of these papers, so 400 papers, 2% of the set, might have been done intentionally. And I say might have been done because we assume that things that had duplicated elements within a photo or that had been rotated or flipped, that those had been done intentionally, and that the ones that were category 1 were honest errors. So does that mean, can we extrapolate this? Does it mean that 2% of all papers, not just the ones containing photos, but all papers in any field contain fabricated or falsified data, contain misconduct? Well, I actually think that the percentage of misconduct in papers might be much higher than 2%, because I only look at the tip of the iceberg. I can see duplications, but if a person is a very good Photoshopper, I might not see a duplication. If a person moved their sample under the microscope a little bit farther, there's no overlap for me to detect, but it's still cheating. And most importantly, if a person just types in some numbers in a database, in a spreadsheet, and makes a figure that looks a line graph, or bar graph or something like that, a heat map maybe, that would be impossible for me to find misconduct in. So I think there's many more cases where a person, if a scientist is smart, and most scientists are pretty smart, they can cheat in many ways that are undetectable. I can really only detect the dumb scientists, the dumb fraudsters who leave traces for me to find, who leave duplications within a photo or across photos for me to find. So the real percentage of misconduct might be much higher than 2%. It might be 5% or even 10%. And that's in absolute numbers of papers, an enormous amount of papers. And it's very likely you have read a paper that is made up or that is contains some form of misconduct. And you might not have noticed that. So we also have in this data set a chance to look at the correlation between impact factor and a percentage of problems. So in those 20 papers we had, so this is a log scale, this is the impact factor. We had some journals with low impact factor, and on general they had a higher percentage of problems, and each dot is a journal. We also had some journals with a very high impact factor, and again this is a log scale. So Science and Nature are out here, and they had low percentages of problems, and some journals did really well. Some journals had very high percentage of their papers with problems, but some other journals did with low impact factor did really well. And so it's overall we sort of had a negative correlation. So the higher the impact factor, the lower the amount of problems. But it's not just a factor of the impact factor. So other factors appear to play a role. Maybe the editor who runs a journal, maybe the type of audience who would submit papers to that journal, or the peer reviewers that are part of that journal's sphere of peer reviewers. Can be many other factors that play a role, but overall a negative correlation between these two. We also did not or were not able to find a correlation between whether a journal was open access or paywalled. There appeared to be no correlation between that. So, and again, these are not paper mills. These are individual cheaters or people who make errors. because these papers are a little bit older, so they're not, I don't think they weren't infiltrated yet by paper mills, which is a pretty recent thing. So we don't think they were, specific journals that were targeted by cheaters. These are individual or groups of papers that might just be from one lab, but we did not find an apparent correlation between open access, the open access model or the paywall model of these journals. We also had, because we had a set of 800 papers, it gave us a chance to look at how often journals would respond. So this set of almost 800 papers are reported to the journals around 2015. So 5 or even 7 years later now, we can make up the balance. How many of these papers have been retracted or corrected? And I feel 5 years, so that's when I made this graph. 5 years is a good amount of time. I gave lots of time to the journal to respond. And I sent a reminder also, like, remind, I have sent you these papers. Can you look at them? And unfortunately, in the majority of the cases, close to 2/3 of these papers there was no action taken after waiting 5 years. No correction, no retraction, no expression of concern. And these numbers appear to hold up. So by now, these are slightly older numbers. I think by now I have 6,500 papers that I found and around 2,700 or so reported to journals and institutions. And my work has led to close to 900 retractions and corrections. But still, in at least half of the cases, the journals do not appear to take any action. No retraction, no correction. And that is sad. It makes me mad. It makes me mad that people cheat, but it makes me even more mad that the journals, the publishers, don't seem to care that much. And they just look the other way. They don't really take care of the customers who are knocking on their door with complaints about a faulty product. They're like, yeah, whatever. You bought this car, the wheel fell off. Yeah, I'm not going to give you a new car. I'm not going to pay you back for this car that you just bought. No, once they have sold their paper, they don't seem to really care about the customer complaining. And that's bad. That's really bad, because we pay so much money to scientific publishers. They should care about quality and about customer service. So, because I'm so frustrated, I've reported these papers to the journals and to the institutions. But now I just want to warn the reader, because they might not have any idea of a big problem with the paper. So I'm posting on poppeer.com, and I would recommend that you install the plugin that they have. So it's a little thing that runs in the background. You go to poppeer.com or search for Poppeer plugin, and it will work with your browser or with Zotero if you use that as a reference manager. And once it recognizes that a paper has a comment on Poppeer, so you can leave comments on papers. If you do a literature search, you will see these green banners appear, because the plugin runs in the background. And it recognizes the DOI of a paper, and it will tell you, oh, there's a comment on this paper. And you can click on it, and you might see that there's a big problem in that paper. So it works really well if you do a literature search, or if you maybe want to work in a particular lab, check out the author's name and see if they have papers flagged on Poppeer. I will have to say that my papers have all been or most of them have been targeted, because I have a lot of haters. And so, yeah, don't just use the number of comments on Poppeer as a measure. Also click on some of them if there's real problems with a paper, because some of the Poppeer comments are just remarks or questions. So it doesn't necessarily mean something bad, but most of them are problems in images, because images are so visible. Now, I've started to do this work in around 2014 using my eyes. But of course, you might argue, well, software is going to do better. What about AI? AI, artificial intelligence, is sort of the new buzzword. And yes, people have started to develop program software tools to detect these duplications. And of course, journals are very interested to use those tools to screen their manuscripts with, or at least the images, similar to the way they use software to screen for plagiarism. So I'm using now an image twin, which is really working well. It also gives a lot of false positives. You still need a human to look at all the things that have been flagged, Most journals, I think, are working with Proofik, but I don't have access to that tool, so I cannot really say much about that. But also, artificial intelligence can do wonderful things and detect maybe these problems, but it can also be used to generate problems. So I'm very worried about how AI can be used to create fake images. If you look at the faces, these two photos of people, they look pretty realistic, but they're generated using AI technology. And so these images look real. And we can, as humans, we have a lot of brain capacity looking at faces and recognizing faces. If these images look convincing, how much damage or how many fake images can AI not create? And there's DALL-E, which is one of the AI tools that if you type in some text, it can generate photos of cells, and these photos look pretty realistic. And so if we can do this in 2022, how much can AI do next year? Probably much more. So I'm very worried about these technologies being able to create convincing looking, unique photos that would never be detectable as being fake. So maybe I'm a little bit pessimistic, but that's where we're heading. I have a slide about paper mills. We just heard Anna Albekina talk about that, but I want to mention it here that these are huge problematic paper sets. So maybe the images I've looked at so far are created by labs that are maybe, not very honest, but now we're talking with paper mills about organized crime, about companies that sell massive amounts of papers to the authors who need them. And these problems are mainly created because of government issued regulations. We all feel the pressure to publish, but in some countries like China and Russia, there are very strict requirements on how many papers you should publish in order, to get your master's, or in order to get your PhD, or in order to get a promotion at a medical university. And in some of these cases, the requirements are so strict and impossible that scientists or medical doctors feel the need to buy a paper in order to tick that box and go on with their career. And they see it as an investment in their career. They don't seem to care too much about the damage they're doing. And so this is a huge problem. We just heard about it. So, but I want to mention it because I'm very worried about, also in combination with AI technology, how this can be misused to generate photos. And just as an example of one of the paper mills I've worked on, not published in any, low impact journal, like pretty reputable journals. These are 4 graphs from 4 different papers, but it's the same graph. I hope you can recognize looks a little bit like a person running behind a football, perhaps. And you can see that, or parts of that, in all these graphs. So the graph is almost the same, but the numbers are slightly changed. The correlation factors are changed. Some dots have been added, some dots have been removed. But these are from different authors in different hospitals in China. And yeah, there's a set of 200 papers using graphs like these that are, they have different graphs, but they reuse the same graph in different papers. There's another paper mill I've worked on, the stock photo paper mill, that used the same image. It's hard to see here, but these are the photos zoomed in slightly differently and rotated, but used the same photos all over a set of 125 papers, reusing the same photos, but again, published by different authors in different journals. And we can talk about, there's many problems that can happen in scientific papers. So there are also fake authors, and some of these cases are fascinating. There's fake peer reviews. We just heard also from Anna Albekina about how sometimes peer reviewers can be fake. They can be suggested by the authors. So the author might send in a manuscript saying, here are some people who can peer review my paper. But the author could have made up those email addresses and basically is peer reviewing their own paper. Well, of course, it's a wonderful paper. Or there can be groups of authors who make a deal with each other. Let's all peer review each other's papers and always do it favorably. So these are called peer review rings. And there's interesting stories on Retraction Watch that you can read. I did not work on any of these cases, but it's interesting to see how, if we care about metrics, there will be people who found ways to be creative and to fool the system. And peer review is just not set up to detect these types of frauds. And then there's people who suddenly discover they have published a paper, but they had no idea. So their name was used maybe to lend credibility to another group of authors. Because of course, it is very hard if you don't work in a US or Western European country, it is much harder to get your paper published. And I'm very well aware of the bias that even peer reviewers and editors have in accepting papers. If a paper comes from Stanford or from Yale, it has just because it has that affiliation, it has a much higher chance of being accepted. And that is wrong. I completely see that. But to use another person's name or affiliation to lend credibility to your paper is also wrong, but people do that. And so this is a potential new problem that people have discovered. And there's so many things wrong with scientific papers that I wish I could split myself up in 100 different persons working on all these problems, but there's just so many of them. And then these are two interesting cases that I've worked on a little bit myself, of people who have made up, I think it's real people, but they have made up fake institutions. So this particular person claims to work in this in the Felnet Health Research Foundation, which appears to be just an apartment. But yeah, so it doesn't sound like a big institution. He also claimed to have degrees from Harvard and other big name universities, but that was all made up. But he does these studies on let's say unusual types of sex, and he claims to interview people on forums, and he had permission to do so, that he had permission to do medical research on human subjects. And the permission was given by the Felnet Health Research Foundation, which I believe is just himself. So basically, he gave himself permission to do research on humans, which is unethical. And so I'm trying to flag all these papers. I believe he made up all these data, but the journals do not want to retract these papers, unfortunately. They think, well, he claims to have permission, so we believe him. And then this guy is very interesting. I've removed his name. He claims to work at the California South University, which he made up. He made up a whole website. It's very interesting. Look at that. Look it up. And it's the address of the university is a home address, which I haven't, don't want to mention that, but I think there might be other people living there, so I'm not quite sure if they're in the loop. But this person has made up many papers and publishes them. Actually, these are published in predatory journals, and I believe he gets some kickback of publishing there. But it's a very interesting story to read up on. There's many websites on this fake author and this fake California South University, which doesn't exist. And then finally, there's all kinds of problems. So the work that I do, basically criticizing other people's papers, of course, is not always met with warm, fuzzy feelings. You can imagine that if your paper is criticized by another person, you do not appreciate that. And so I have several groups of haters who will follow me on Twitter and will, accuse me of all kinds of things, because I guess the counterattack is the best. If you are accused of faking data, I would, if I was an honest person, I would try to show that I really got approval by an ethical committee, or that I really made up this data, really measured this data. I would try to prove the accuser, the whistleblower, wrong. But if there's nothing to prove, I guess the best strategy is to counterattack the person who accuses you. So this is a popular way, just make the other person ridiculous. And so there's this one professor from France in Marseille who claimed that hydroxychloroquine could be used to treat COVID-19 patients. The paper that he published was tweeted by many world leaders, including Donald Trump, who was the president of the US. Many people wanted to use hydroxychloroquine as a preventive to prevent COVID-19 infections. It turns out it didn't work at all. But this paper had many flaws, and I wrote a big critique about it. And then he counterattacked me. So he made these videos. Who is Madame Bic? He never called me Dr. Bic, but he sort of denigrates me to Madame Bic. And he called me all kinds of nasty names. He actually threatened me with a lawsuit, which so far has not happened yet. It's just a threat. But he said, I'm going to sue her, and I'm going to, you know, she'll end up in jail. And he had lots of people on Twitter supporting him. So my Twitter feed became very nasty. But luckily, there were many people in the scientific community who started petitions to support me. And I'm very grateful for their support, because I feel I've done my scientific duty. And I flag these papers, but I try to be polite. I don't call him any names. I just point out that certain things appear to be missing or are not maybe correct. And yeah, he just counterattacks me. So it's nasty, but it's a risk I'm willing to take. I might be scientifically ruined doing this work, but I want to take that risk because I feel somebody needs to stand up to science. So this is my last slide. How can we prevent misconduct? Well, we can talk about open science and good research practices. That will make it harder to do misconduct, but not prevent it. We should focus less on productivity and impact factor and measurement to measure our productivity, but it's hard because we all want to publish new results, but we should publish maybe a little bit more reproducibility studies. There seems to be all kinds of conflicts of interest between publishers and institutions who do not want to investigate these cases, maybe because they're embarrassed. We need faster outcomes of these cases. Why does it take 7 years to retract a paper if it's a 5-second decision, in my opinion? The fact checkers, so people like me, whistleblowers, however you want to call people like me, we need to be either paid but definitely protected from a legal point of view, as long as we remain polite, of course, which I try to do. And there need to be better punishment for the fraudsters. Too many times the fraudsters keep on frauding and there's no punishment. I'm very worried about AI, sort of dual use research. We can use it to do wonderful things, but it can also be used to do very bad things. And then finally, there's a tremendous cost of misconduct. We, not only for the scientists trying to reproduce these papers with fabricated data, but also for science as a whole, because it adds to the confusion that the general audience has. If there's all these retractions, which as a scientist, I think is a good thing to retract bad papers. But for the general audience, they might interpret that as, well, maybe all science is flawed and we should just not believe in science at all. We should not believe in vaccines or global warming. And so it can add, you can walk away from my talk thinking all science is bad and we should give up on science. But I do not want that to be the message of my talk. I hope you agree with me that we need science to fight the problems we have in the world, like pandemics and climate change and pollution. We need science, but we need science to be good. So I hope to contribute to that. Thank you.
So, Dr. Beek, thank you very much for this fascinating talk. The questions and comments I'm receiving through Slido are stating the same. So we will promote your talk afterwards for sure, because I think that it is necessary that even more people watch this recording. I have quite a few questions for you. So I would like to begin with asking the audience here in person. Does anyone has any questions for Dr. Beek? Yeah, okay. So just a moment. Yeah, okay. Okay, so we will get you the microphone.
Well, thank you very much, Mrs. Beek, for this talk and also for your work you do. And my question is, for me, it's very hard to understand why the journals are not responding or why they're responding so late. So maybe just
I don't know either.
An idea or like an opinion or just like, yeah, would like to hear, from you. Thank you. Thank you.
Thank you. No, it's a good question. And of course, I thought about it. I thought initially, I write to the journals and they're all going to be very responsive and retract these papers or correct them. But I think there's a range of different reasons why they don't respond. So first of all, I send batches of papers to these journals. I said, oh, I screened 200 of your papers and I found 10 problems in them, for example. And I think some of these editors were just overwhelmed, right? I found 10 problems in your paper and you're like, what do I do with it? Let's just ignore that email. I think that's a very human response to if you have a very big problem, to ignore it. There have been cases where, you know, the journal editor might have responded and sent an email to the author, but the author has moved on to a different university and their email address doesn't work anymore. So it's sometimes very hard to hunt down people, hunt down their new email addresses. You know, academics sometimes move around a lot. Or the author's email address might work, but they might choose to not respond. And so it's very hard then for the editor. I think a lot of them feel they're not in a position where they can retract the paper without giving the authors a chance to respond. And I think it's fair, but if an author never responds, none of the author replies, then I feel an editor should have the power to retract the paper or correct it, or at least flag it with something like there's a big concern about this paper. And then in some cases, authors have threatened to sue the editors. And so an editor might say, okay, we think there's a big problem. I'm going to slap an expression of concern on your paper, or I'm going to retract it. And then the author said, well, I'm going to sue you. And I think a lot of editors are then scared, you know, a lot. And I would be too. But I have been threatened with 2 threats of lawsuits. And in both cases, I said, well, I'm going to ignore it. And maybe that's very naive of me. But yeah, I ignore it. And so far, there was no real lawsuit. But there have been several authors who are, you know, the case of the social spider case. I'm not going to mention this guy's name, but he threatened to sue editors who were saying that they were going to retract the papers or put an expression of concern on them. So there's a range of reasons, but it's very frustrating. I do believe part of it is that journals just, find it too hard to deal with and maybe damaging for their reputation.
Anyone else? No one? Okay. So now I will ask the questions on behalf of people who submitted them through Slido. So the first one is, how much time does it usually take you to review the quality of an image? And do you use any specific image analysis software, or do you work just, let's say, with your eyes and brain?
Initially, I did everything by eye. So that set of 20,000 papers, I scanned by eye. I didn't have software back then. This was a couple of years ago. It took me on average about 1 minute per paper. So not per image. And this is an average. I mean, some papers have lots of images, so it took me much longer. And some papers had just 1 image. So it's seconds, right? I mean, the downloading of a paper, then finding the paper, downloading it, opening it almost takes more time than just look at 1 image. So if it's just 1 image, I'm like, okay, that looks good to me. Within a minute, I can do most of these papers. Some science and nature papers will take longer. I usually did not look at the supplemental. I only looked at the images. If I found a problem, I would also scan the supplemental, but that's how I did it. So now I'm using software. So I'm using Image Twin, which is not open access. So it's I have an account for free, but I think the company wants, of course, hopes to sell their product to publishers, so they don't make it free. Fig Check is one that is free, but you can only screen, I think, 5 papers per day. So that's another. That Fig Check is free. I showed that also in my slides. And there's a couple of others that are not free. There's Forensically, there's Sherlock. So there's a couple of these softwares that I actually listed on my website, scienceintegritydigest.com. You can go there, and I have a frequently asked questions and how to do things. So I've listed all these links there, so you can check them out. And the software helps me to find much more, but it also creates a lot of false positives. So it also creates more work.
Okay, thank you. So next question was actually, I think, asked to Dr. Abalkina, but it came in too late. So I would like to ask you to answer instead. And it is, what are the most effective ways for editors to notice a case of paper coming from a paper mill or a fraudulent paper?
Well, those are two separate questions, although, you know, fraudulent papers can include paper mill. So it's tough because these, as an individual papers, you would not recognize it necessarily as a paper mill. It's only when you see the whole pattern that you see, oh, all these papers are very similar. They seem to be written on the same template. But I think some of the things that Dr. Abalkina mentioned are obvious. So like, well, first of all, are the authors all from different countries? That is unusual. Have the authors published previously? If none of them have published previously, is also very unusual. Most, you know, usually there's at least one experienced scientist. Are there do the affiliations make sense? If you are a dentist, would you work on, I don't know, glaciers or so? Like you would not expect certain people to work on certain topics. Or are the affiliations very, you know, very different between all these authors? How would they have ever met each other? Are the email addresses institutional? And some of these things, they're just red flags. It's not a proof that a paper is fraudulent, but it's a red flag. And together you can sort of have a big suspicion. And of course, the next thing would be to ask the authors for the original data. And if they cannot provide that, especially when it's a new paper, they should still have the original data. And if they have then some fake excuse like, well, I don't have the data, or, well, we outsourced it or so, then I think you'll have, as an editor, you have a little bit more proof that the paper was fake and you can retract it.
Yeah, okay, thank you. Another question is, could open peer review be part of the solution to the image fraud problems that you talk about?
I think it can help detect citation rings, so problems with peer reviewers who are fake. I'm not sure if it could, if open peer review as opposed to closed peer review could solve the problem of detecting images. I think most peer reviewers are not really trained to detect fraud or to detect problems with papers. So I post a lot on Twitter, and I hope that people will look at papers in a slightly different way. You sort of review the paper for scientific content, and then sometimes you can spend an extra minute or two thinking about, could this be a fraudulent paper? Could the images be you know, fake, or do they contain photoshopping? And I think it's fair to ask that of a peer reviewer, but I don't feel that we can hold peer reviewers who are unpaid, who have limited time, who do it as a volunteer part of their job, which is, you know, the strange way we academics work. I don't feel we can hold them responsible for finding it. So I feel that that part needs to be done by a paid person, a person who is very, like a person like me, who is experienced in finding duplications, images, but also papers need to be screened for other potential problems with statistics, for example. And I feel as a peer reviewer not qualified to review the statistical part of a paper. So I always hope that one of the other peer reviewers is that, or that the journal can hire and pay a person to look at these problems from a statistical point of view. And then you can have a paper screened for ethical problems. You know, was there the proper permits obtained? And so every paper I feel should be screened by a couple of experts, not from a point of view of peer review, but from a point of view of screening for very big problems and fraud. And that needs to be paid, and it needs to be paid by the publishers. That's my opinion, of course.
Mm-hmm. Okay, thank you. Then the last question through Slido, unless there is a viewer still who wants to send us some more. You have probably 5 more minutes. This person first started with a compliment to you. They say all publishers should have you on their board. And,
well, I love to be independent.
And then they ask, have you thought about organizing a summer school where you would share your skills?
Well, I give a lot of talks like these, and I hope that is appreciated. I'm not sure if I can share my skills. Like, I feel you either have them or you don't, and I have, of course, a lot of experience, so I can sort of, basically it's me staring at an image. I'm not quite sure if there are people who see the duplications also, and I feel about half of the people see them, and half of the people just will not be able to detect it. And so I'm also very bad in detecting or recognizing faces, which most people can, but I'm very bad in that. Now I hear an echo. I'm not sure if somebody pressed some button somewhere. Okay, it's gone. So it's I'm not quite sure. I give a lot of talks like these. I post on Twitter. I feel I'm not quite even sure how to organize a summer school, but I hope that people come to these talks and learn from that and play the game on Twitter. So go to Twitter and play the game with me, image forensics. It's like I try to post one problem a day and see if you can find the problem yourself.
Okay. Thank you. And since I received no more questions through Slido, I would like to conclude this with one of my own, and that is perhaps the most provocative of all questions today. Are you concerned for your safety, your physical safety?
Physically, well, sometimes a little bit. There have been some occasions where there were big, like I worked on a big set from a big name university, a big name immunologist from a certain country, and people said, "Oh, well, your Twitter account is going to be hacked. That's not physical safety." But then, yeah, I was looking over my shoulder a little bit more because people have posted my home address online, and some of these Twitter accounts have, like 1 million followers, and so they can, if they post my home address, that leads to a lot of people, and it only takes one crazy person, right, to find me and do something to my home or do something to me. So I'm a bit worried sometimes, but most of the harassment has been just online. It can still be very hurtful, and I have cried, and it's stressful, but I feel at least I'm in a position to take that risk. I do not wish that a more junior person would do this, because I'm like more, I don't know, at a later stage of my career. I don't really worry about my career. I'm not affiliated. I don't have a boss who tells me what not to do. And so I'm at a privileged position where I can take that hate much better than anybody else. And I would recommend nobody to do this type of work. I don't think it's a very good career, because it can be very hurtful. And if you want to post comments on Papier yourself, do it anonymously, because it's not worth the stress that I'm feeling. But I feel, because I do it under my full name, it also lends more credibility to what I'm saying. So I'm I don't know, maybe one day somebody will shoot me down. I obviously hope that won't happen, but I feel somebody needs to stand up for science, and then I guess it has to be me. And any support from the scientific community, any like on Twitter is appreciated.
To the international science. So with this, I conclude today's event. Dr. Beek, thank you very much. Thank you very much to everyone who has been with us until this point. Thank you to all of our viewers online. All of these recordings will be available for later watching on YouTube. So you are welcome to watch them again, and share them through your social network. Thank you and good evening.